So trigonometry is largely based on right triangles. Right triangles and a circle kind of working together defines a lot of right triangle trigonometry. So before we start with trig, something we should do is get a little review of terminology and some properties of our right triangles. So a right triangle, it's right because it has a 90-degree angle, which we often denote with this kind of square in the corner where that 90 degrees is happening. Then just to jump to, there's a property of all triangles. It doesn't have to be specifically right, where all three angles have to add up to 180 degrees. So something we'll deal with a lot is maybe we'll know one of the other angles, but not the other. So to solve, we would use the idea that 90 plus one angle plus the other should all add up to 180. Now for terminology, there are three sides to a triangle, and the longest side is called the hypotenuse. So visually, like with this case, we can tell that this side is longest in terms of measurement, just visually. However, if it's sometimes hard to tell, you can also use the fact that the hypotenuse is always opposite of the 90-degree angle. So you can imagine kind of standing here, and if you look across from where you're standing at the 90-degree angle, that would be the hypotenuse. Then from there, the other two side lengths, they're just called the same thing. They're both called the legs of the triangle. So we have this leg and this leg. Now they can be the same side length sometimes, but most often they're different side lengths. So something we could do if we need to denote between the two different ones is use a subscript, so a number just to differentiate between the two. So we could call this leg 1 and this leg 2. It doesn't matter which one's 1, 2. All that really matters is recognizing which side is the hypotenuse, and then the other two legs kind of just work together. All right, so there's some terminology about the side lengths. Let's get a review of the Pythagorean Theorem. So the Pythagorean Theorem relates the side lengths of a right triangle. And what's key is that you can only use the Pythagorean Theorem if it's a right triangle. So let's get our notation here. So looking at this right triangle, that side C is our hypotenuse. And then the other two sides are the legs. Let me call that leg. Now, what it tells us that we can do, it tells how the lengths of the three sides of a right triangle relate to each other, and that relationship goes if you take the hypotenuse squared. This is going to be weird, but I'm going to write it out in words first. But if you take the hypotenuse squared, that's going to be equal to the sum of each leg squared. So what's key with this formula is that the hypotenuse has to be on one side of the equation. Then the other side is made up of the sums of the legs. Common mistake is to throw in the hypotenuse for one of these leg values, which you can't do. So the hypotenuse squared is equal to the sum of the legs squared. So using the letters that are down below there, the hypotenuse is c, so c squared is equal to a squared plus b squared. And that's our Pythagorean theorem. So this allows us to solve for missing side lengths when we have a right triangle. So let's look at two examples here. So with this one, first thing I like to do with these is just make note of where the hypotenuse is. So I can see my 90-degree angle there, so opposite of it would be the hypotenuse. So in this case, our hypotenuse is the unknown. I'll just call it x. So we're going to have our hypotenuse squared, which is the unknown x squared, equals, and then I'm going to take each leg squared and add them together. And then it's just some algebra and calculator work solving for x. So 16 squared plus 24 squared, a calculator would give us 832. And then we would take the square root of both sides and get x equals. When we take the square root of both sides in algebra, we get plus or minus. However, this is distance, so we're only getting a positive value here. So with this, we can go to a calculator and just grab a decimal. So square root of 832, which is 28.84. And then we just need to grab our units, which we could look at this other side lengths, which are in centimeters, and that would match the units for the hypotenuse. All right, in this next case here, noting which is the hypotenuse first, so across from the 90-degree angle, this 7.125 will be our hypotenuse. So our unknown is actually a leg in this case. So what we're going to do is take our hypotenuse squared, and that's going to be equal to 6.75 squared plus x squared. So I'm not going to simplify quite yet. What I'm going to do is subtract 6.75 squared from both sides. So that would give me x squared is equal to 7.125 squared minus 6.75 squared. And then what we're going to end up doing is taking the square root of both sides. So with that, I'm going to go to the calculator. So we'll get or we can go ahead and throw in the square root. 7.125 squared. If I could type correctly, there we go. 7.125 squared minus 6.75 squared. And with this one, I didn't simplify in the middle of the steps because of those decimals making things messy. So if I just keep those exact values in there, I can get this answer of 2.28 without any error in there. So 2.28, and then for units, it'll be in inches. All right, so that's just a little review of our right triangles, being able to recognize what the hypotenuse is. The property of those three angles adding up to 180 will come in later, and then using a Pythagorean theorem to solve for a missing side length in a right triangle.